Hi guys, welcome back. Today we're looking at solving differential equations with separable variables. What do I mean by separable variables? Well, I mean we have some sort of differential equation that has both x and y, and we can actually separate them out from each other. So whether that be through factorization or any other means. So here I can see an example. So we've got dy of dx is equal to x plus 2 over y to the power of 3 plus 8. So what I can do is I can move these x's and y's freely around the equation. I don't have to perform too much magic to get that particular piece of algebra to work. So let's go ahead and let's do that. And what we're going to do is we're going to pop the y's with the dy's, and we're going to pop the x's with the dx's. So now how do we go about solving these particular functions? Well, what we're going to do is we're going to integrate each side with respect to its particular variable. So the left-hand side we're going to integrate y with respect to y, and the right-hand side we're going to integrate x with respect to x. So let's go ahead and perform those integrals. So now that I've integrated each side and I've added c, I could rearrange to solve in terms of y, I could rearrange to solve in terms of x, or I could rearrange to solve in terms of c. It just sort of depends on what particular function or what particular reason that you're going to use this expression. So for me, if I wanted to, I'd probably just find this in terms of c. So we have y to the power of 4 over 4 plus 8y minus x squared over 2 plus 2x is equal to c. And then that way, if I had additional information, I could go ahead and then solve for c. Let's jump into a more complex problem with separable variables. Here we have a little bit more of a complex problem. So we have variables that are on both sides of the equation, and currently I don't have my variables that are separated. So the first thing that I'm going to do is I'm going to go ahead and I'm going to move all my variables over to the other side. So I have dy over dx is equal to some function. Now, lucky for me, these equations are going to be separable because y squared is a factor of both of these terms. So I can go ahead, let's factorize this out. So we have y squared 2x minus 1. So now this is something that we can separate out. So let's go ahead, let's move our y's over to the left-hand side again, and let's move all of our x terms over to the right-hand side. Now that we have our terms that are all collected together, let's go ahead and let's find the integral of both sides. These ones are both nice easy ones. So y to the power of negative 2 becomes y to the power of negative 1 divided by its new power. And this becomes 2x squared over 2 minus x plus c. So let's go ahead and tidy this up. Specifically, this question is asking us to express y in terms of x, so that's what I've done for this equation. I've done the rearranging first. Let's go ahead now and solve for c. So given that when x is equal to 2, the value of the function y is equal to 1, let's substitute those values in. Now all I need to do is just to rearrange to solve for c. Now that I've found my value for c, we can go ahead and we can pop that back into this original function here. I'm not going to rewrite it, I'm just going to pop negative 1 there like that. Now we could go ahead if we wanted to and factorize this. I don't think that would necessarily help to solve anything further because we've really done what the question has asked us to do. Let's go ahead, let's do one more slightly trickier one, last example for this separable equations video. Alright, last problem here, dy over dx plus 8x cubed y to the power of 4 is equal to y to the power of 4, and when x is equal to 0, the value of the function y is equal to 1. So let's go ahead, let's rearrange this so we have dy dx is equal to y to the power of 4 minus 8x cubed y to the power of 4. And now what we can do is we can factorize out that y, and then we can separate these equations. That's really the key thing with these, is that we have some way, whether through factorizing or some other means, to separate out our y's from our x's. Okay, so now that we've done that, let's go ahead and rearrange so that our y's are with our y's and our dx's are with our x's. Next, we're going to integrate both sides with respect to their corresponding variable. So the integral of y to the power of negative 4 is going to become y to the power of negative 3 divided by its new power, negative 3. And the integral of 1 minus 8x cubed is going to become x minus 2x to the power of 4, because we raised that by 1 and then we've divided through by the new power. And then we can add c on this side. Let's go ahead, let's rearrange this one. So we have y to the power of negative 3 is equal to negative 3 lots of everything on the right-hand side here. And then because this is 1 over y to the power of 3, I'm going to inverse or flip both sides. And the last thing that we'll do is we'll take the cube root of both sides. So now what we can do is we can go ahead and solve for c using that additional information. So I know that when x is equal to 0, that y is going to be equal to 1. So I can substitute in those values. And the last thing I need to do now is rearrange to solve for c. So generally this is why I don't rearrange when I'm solving for c, because basically we just have to reverse all this process anyway. But really it doesn't make a difference either way that we choose to do it. And we have c is equal to negative 1/3. So we can pop that back into our equation. So there we go. So that's how we solve differential equations that have separable variables. So keeping that in mind, if we cannot separate the variables, then we can't actually use these techniques. And of course, we want to try and use the simple techniques we can to solve first. And if not, we'll have to move on to more complex procedures. Alrighty guys, so that's it for the video today. I will see you in the next one.